Okay, Mersenne primes. What is a Mersenne prime? Well, let's just take the formula 2 to the n minus 1. Let's evaluate that. For n equals 1, we get 2 to the 1 minus 1 equals 1. For n equals 2, we get 2 squared minus 1, which is 3. For n equals 3, we get 2 cubed minus 1, which is 7. For n equals 4, we get 2 to the 4th minus 1, which is 15. For n equals 5, we have 2 to the 5th minus 1, which is 31. For n equals 6, we get 2 to the 6th minus 1, which is 63. For n equals 7, we get 2 to the 7th minus 1, which is 127. Now, is there any pattern going on here? Well, we're talking about prime numbers. And let's note then that some of these aren't prime. Okay, well, first of all, for n equals 1, you don't get a prime. We'll just discount that. For n equals 4, 15 isn't prime. I'm going to cross that out. For n equals 6, 63 isn't prime. Now, all the others are prime. The pattern that we're beginning to see is, well, after 2, for odd numbers, 3, 5, 7, and so forth, maybe odd numbers always give us primes. Well, it turns out that that's not the case. If n equals 9, you get 511, and 511 is divisible by 7. Okay, so that if we try to go on to the next odd number, n equals 9 doesn't work. But n equals 11, well, you can check out n equals 11 and see if that works. For n equals 11, you get 2047. The point is, and I think, let's see, 2047, I think 2047 isn't prime, but I'm not even sure right now. Doesn't really matter. The pattern doesn't always continue, but the pattern that we want to kind of speculate on is that when n is prime, 2, 3, 5, 7, is that prime? I think that's the first one that they found that wasn't prime, and it took them a while to prove that. I could be wrong about that, but it's a number. If it isn't n equals 11, then it's n equals 13. That doesn't give you a prime. However, the key is that if n is odd, two to the n minus 1 is I just said it wrong. If n is odd, if n is prime, then 2 to the n minus 1 is very often prime. And if n is not prime, then it turns out that 2 to the n minus 1 is much less often prime. And there are some reasons for that, but yeah, you might speculate on what those reasons might be. And then down here I actually say, yeah, it's true. The 2 to the 11th minus 1 is not prime. Now, 2047 equals what times what? This is kind of an interesting problem. You can probably find this using a calculator. This wasn't proved till about within the last 500 years, and people had perfectly good arithmetic before that. Either they weren't very interested or their arithmetic was just too cumbersome to manage this. Their number system wasn't sophisticated enough. But for us, it's pretty easy. You could just sit down and do long division for an hour and find a number that goes into 2047. I'll note that both of these numbers have to be less than 43. Why is that? But they're not both less than 43. One of those numbers is less than 43. Must have been late when I wrote down that both. The reason one of those numbers is less than 43, why? Because 43 squared is bigger than 2047. Actually, I won't guarantee that 43 squared is bigger than 2000. It's not, but the next prime after 43 is 47. The next prime squared is greater than 247, so that 2047 over 47 is less than 47, right? And 2047 divided by something bigger than 47 has to be even less than that. Now, if you divide by a number bigger than 43, then you're either going to get something like 47 or something less than 47. If you get something less than 47, I wrote that wrong. Excuse me for botching up this argument. This would have to be less than 43, actually. And it's not equal. It's just plain less than. So the point is that if you divide your 2047 by 43, you get something less than 43. I'm having a problem because I don't have room to write this down. I might have to come to it in another clip, but I'll say it quickly anyhow. 2047 divided by 47 would have to be less than 43, in which case there'd be a prime less than 43 that divides it. If you divide this by something bigger than 43, it turns out either you're going to get something less than 43 or a prime, something less than 47 or a prime less than 43. And either way, one of your prime factors has to be less than 43. And I really need to write that out for you. And apparently also to keep my own brain straight on exactly what I'm saying here. So let's come to that in another clip because it's kind of an important property of primes.